These are the 1.4 notes for PreCalc. We're going to be talking about combining functions today. So mostly this is just working on the setup and the language of it. All of the math we've done before, adding, subtracting, multiplying. So first example, they give you two functions, f of x and g of x, and they want us to complete these four operations. The first one you can see is adding. And they write it like this on the problem, but you could also write it as f of x plus g of x. So those two things mean the same thing. And all you're going to do here is combine like terms. So we'll write the expressions out, the functions. The f function plus the g function. So look like that. And then you just combine like terms. 2x and 8x, 10x, minus 7, negative 7 and 3, negative 4, minus 4. And there we go. For subtraction, again, they could write it as f minus g of x, or they could separate it and write f of x minus g of x. Those mean the same thing. So for the subtraction, we'll do 2x minus 7, subtract 8x plus 3. And oftentimes with subtraction problems, a lot of mistakes are made because you have some minuses as well as some negatives. So I always encourage people to distribute the negative. In junior high, 9th grade, you might have heard the phrase keep, change, change. That is just kind of a shortcut way of distributing the negative. So I'm going to put a negative 1 there and distribute that, which means we'll keep everything in the first parenthesis the same, change the middle sign to a plus, and then change the signs in the last parenthesis. And that just makes it less likely for you to overlook that minus sign in the middle. Then you just add as normal. All right, for multiplication, again, they could write it as f times g of x, or they could write it as f of x multiplied by g of x. And so we'll take these, and most of the time this is going to be either a distributing or a foiling problem. So this problem right here is a foiling problem. You're multiplying a binomial times another binomial. So 2x times 8x, 16x squared. 2x times 3, 6x. Negative 7 times 8x, negative 56x. And negative 7 times 3, negative 21. And then, of course, we would just combine any like terms you have. All right, and the last one we're going to talk about is called composition. Notice it's this little circle, open circle here. It's different than the multiplication symbol, and this one means composition. So we're going to be plugging one function into the other. So we can write it as f of, and you say it as the word of, f of g of x. Another way they write this one is f parenthesis g parenthesis x. So it's almost like the g is enclosed inside the f function. So we plug in one function to the other. Plug in one function to the other. So for this one, we're going to start writing the f function 2, because f comes first, so we're going to write the f function. That's going to be the one on the outside. And the g is going to be the one that we're going to substitute it in. So right here in the x, instead of writing the x right there, we're going to substitute in the entire other function, 8x plus 3. And then finish the rest of the f function with a -7. So what used to read 2x minus 7 now reads 2, and then we plugged in the g minus 7. From there, just do whatever order of operation you need. So distribute, and then combine like terms. And there we go. All right, example number 2. We're going to try to set these up. So we'll make a little note. We're going to do setup only on these. So you have 2 new functions. Again, you could also write this as g parenthesis f parenthesis x. Remember, that's another option of how you can write it. So we'll start with the g function, 3. And then when x gets there, we're going to substitute in the other equation, the other function. And finish off with a -4. So that's our setup. Normally we would distribute and combine like terms. We've had enough practice with that. You should know how to distribute. So I'm mostly concerned with the setup. On the second one, part B, see if you can set that one up. Start by writing the f function first, and then plug the g function into it. Start by writing the f function, and then when you get to the x, put in the 3x minus 4. You still have this squared on the outside, so make sure you copy that down, and plus 2. Again, we're not going to take the time to go through the math on that one, but for this problem on the right, you would have to write out the 3x minus 4 and square it. Okay, on the back side, composition with numbers. Now instead of x's, there are going to be numbers here. There's a couple different ways to do this, but the way I found to be the most efficient is to take the 1 and first plug it into the g function. So take the 1, plug 1 into the g function. So it's going to go in right here. 4 times 1 is 4. Then after that, you still have this f on the outside. So now we're going to take that answer, plug 4 into the f. So it's almost like you're doing 2 substitution problems. 2 times 4 squared minus 3. That's 2 times 16 minus 3. 32 minus 3. Final answer of 29. So both of these are not answers. Just the 29 is your answer. Right, we'll do the same thing with the next one. See if you can plug 5 into h, get an answer first. Then take that answer and plug it into g. All right, there we go. 188 is the final answer. Okay. Example number 4, they're just showing you an example here where you have 3 functions instead of just the normal 2. So you have f of x, g of x, and h of x. And we'll start by plugging 2 into the h, always the one closest to it. You kind of work from the back forward towards the front. 2 goes into the h. That gives us 8. And then next we're plugging it into the f. So 5 times 8 minus 1. Final answer, 39. Part B. See if you can try this one. Plug -3 into f, and then plug that answer into g. All right, so -3 into f, -16, and then when we plug that back into the g, we get a negative of negative 16, which gives us positive 16. All right. The last part we're going to talk about here is composition with graphs. So instead of having to plug in numbers to get it, we are simply going to look at our function, our graphs. So first problem, h of f of 1. So what we're going to do is look at 1 on the f function, on the f graph, and see what y value it links to. So on the f graph, I see here my x is 1. So I want to take the answer of 4. That's like getting the first part of the problems we were working on before. Now what we'll do is we'll go over to our h function and look for where 4 is the x value so that we can find the y value that goes along with it, which would be an answer of 3. Notice one thing. There are lots of different numbers here that repeat. You're always looking for the x so that way you can find the answer of y. Let's try the next one. G of 2, so let's look at our G graph. Find 2 as the x, write down the y value. And then use that as the new x value on your h function. So come over to your h graph, look for 0 is your x, final answer 3 as the y. Take a moment, try the next two. On the F graph would give us 2, and then 2 on the G graph gives us 0. Then 3 for the last one, 3 on the F graph. That's right there. So we're going to use the y value 3, bring that over to the H. And again, you have a couple different 3s. We're looking for where it is in the X position so that we can write down the Y position. Don't take this 3 or that 3. You're always looking for the first 3, the one that shows up in the X position.